Hi everyone, thanks for watching. In this video, I'm going to go over how to write chemical equations that accurately model chemical reactions. Remember from the last video that chemical reactions are just changes in matter where the atoms rearrange to form new chemical substances like the phosphorus, potassium, chlorine, and oxygen atoms in the tip of a burning match that rearrange to form these two new compounds, or the sodium, hydrogen, carbon, and oxygen atoms that rearrange to form these three new substances while you're baking cookies. The question for this video is going to ask, is there a way to model these chemical reactions that is easier than drawing out every individual atom and how it's attached at the beginning compared to how it's attached at the end? The answer to this question is, of course, the chemical equation. This is the quickest and easiest way to model chemical reactions and how they happen. What makes it so easy is that we use chemical formulas instead of drawing out each individual atom. And we use those to represent the initial substances and the new substances after the atoms rearrange. You've seen chemical equations before, both in this series of videos and probably other science classes too. A chemical equation starts with the formulas for what we call the reactants. The reactants are the initial substances, and they're written on the left-hand side of the arrow. On the other side of the arrow, we've got the products. The products are the new substances after all the atoms rearrange, and those products are always written on the right-hand side of the arrow. Now let's take a look at some of the symbols you might see in chemical equations that you might not be so familiar with. Here's a reaction between magnesium and oxygen gas. The strip of magnesium that you see here actually kind of catches on fire when you supply some heat in the presence of oxygen. When you write this equation, you might sometimes see it written with parenthesis S, parenthesis G, parenthesis S. These symbols are simply trying to give you more information about what each substance is like. S, for example, means the substance is a solid, like the magnesium was, and like the magnesium oxide product will be. Parenthesis G means that the substance is a gas. Here's another chemical equation. You can see the H2O has parenthesis L. That means that substance is a liquid, of course, because it's water. The other substances have the symbol AQ. AQ stands for the word aqueous, and aqueous means that those things are dissolved in water as the reaction takes place. Here's a third example of a chemical equation that's got two aqueous reactants. That means they're both dissolved in water, but the product has this weird symbol PPT. To understand this, let's actually look at a video of this reaction taking place. You'll notice there's one solution up here in a dropper being added to a different solution down here in the test tube. When they combine, we get some new yellow product that sort of falls towards the bottom of the test tube. That new yellow product is falling because it is a solid. It's a little bit more dense, so it sinks to the bottom. When solids are produced from two aqueous solutions like this, that solid is referred to as a precipitate. And it's called that because it sort of falls to the bottom, much like rain or snow precipitates out of the sky. The symbol for a precipitate is PPT. And here's one final symbol in this equation. You can see a triangle, or the Greek letter delta, that's written on top of the arrow. When you see this, it means that heat needs to be supplied to make the reaction happen, much like when you have to light a Bunsen burner using a striker. So let's pause and take a moment to put all these symbols in one place on the screen. Make sure you've had a chance to write them down. They make up the key ideas for this video. Let's conclude the video by talking about how to write chemical equations yourself. And eventually you'll be able to predict and write entire equations totally on your own. For now, we're just going to focus on writing these equations from written descriptions of reactions called word equations. Here's an example of one that says aluminum metal reacts with oxygen gas to produce aluminum oxide powder. To turn this sentence into a chemical equation, remember that you just have to identify the reactants first, followed by the products. Usually this is pretty easy to find. You'll see words like reacts with. So aluminum metal reacts with oxygen gas tells you what two formulas to write on the reactant side. My product can be found where it says to produce aluminum oxide powder. So on the right-hand side of the arrow, I put the symbol for aluminum oxide. That concludes this video on writing chemical equations. Here's a brief summary.